Hi, my name is Stefan Kaler, and this is the second part in our video series on how to make your data warehouse ready for AI. If you haven't seen the introductory video, I highly recommend you go check it out. That gives an overview of all the different steps that you want to take during this process in order to make your data warehouse ready for AI. In this video, we're going to be deep diving step one, which is exploring your data warehouse properly to get the right information so that you can feed into the context of the AI. Currently, you might find your warehouse is a little bit too cumbersome to navigate. Maybe you've got thousands of tables, and so implementing these steps is really difficult. I recommend that you still try to go through them, but in the case where your warehouse is a bit challenging, you're going to need to probably make some modifications to your warehouse or maybe even re-architect it. And so we're going to cover those steps in future videos. But for now, we're just focusing on the exploration. So without further ado, let's dive in on how to properly explore your data warehouse. My slide will progress. There we go. Cool. So first things first is you need to identify your raw data sources. Raw data is the most important and most fundamental building block of any data warehouse because everything that you build within the warehouse is derived off of it. This sounds trivial, but I've started a lot of roles where the team isn't even aware of what their raw data is, and instead they're using some downstream table that was handed down to them by the previous team that is known for being trustworthy. And then when they actually start to dive deep on that table and investigate it further, it turns out that table really wasn't that trustworthy. And as a result, all the conclusions that they've derived, all of the models that they've built, all of the reports that they've built might be slightly flawed as a result. So you really want to make sure you have a good understanding of the most raw form of truth in your warehouse. You want to understand how that raw truth or that raw data has been manipulated throughout the warehouse, and you want to make sure that the warehouse logic retains the truth of that raw data as best as it can. So we're going to talk about some steps, some methods that you can use to identify your raw data sources. So sometimes, as I said, you won't have your raw data sources clearly laid out for you, and you'll need to follow the code, the transformation logic, all the way back until you get to the raw data. Sometimes the raw data is just dropped into the warehouse from some upstream system that you're not aware of. Sometimes it's pipelined in, sometimes it's subscribed via some system. There are a bunch of different ways the data can get in, but you generally know that you've hit the raw data when the logic is basically ends. Some programs will automatically discover what your raw data sources are for you. They can be very helpful to use when going through the exploration phase, but not every program does this, and you might not have access to that program. If you're using dbt, often you can find raw data in the sources.yaml file if that's been maintained, but keep in mind it requires a person to maintain the sources.yaml file, so that might not always be the case. It might not always be up to date. Ideally, you do have it documented somewhere, and each data source has its own documentation, but once again, that's ideal and very rarely a reality. So you'll likely need to talk to various software and data engineers in your department to piece this information together. You'll have to follow the code all the way through. That's the rawest and most manual way of doing it. But eventually, ideally, you do find a way to pin down what your raw data sources are. Once you've pinned them down, I classify raw data into two different groupings. There's internal raw data. This is data that's produced by your department as part of the application your organization is responsible for. You know who codes out this data and then emits it to you, and you can easily partner with those stakeholders in order to change the data points so that you can get the data points that you need. Then there's external raw data. This is data that comes from outside your department or maybe even your company. You have minimal control over it because you're sourcing it externally. And so if you want to make a change to it, it's unlikely that you will be able to. So once you've identified your raw data, you're going to want to deep dive on it. We'll talk about that in more depth in the next video. For now, we're going to continue with exploration. The next step is to explore your data warehouse's lineage. Lineage is the study of how data flows through your warehouse. Getting a visualization is very helpful for quickly understanding what's happening in your data. This slide sort of represents what you'll see visually, but ideally there is a program that you can use to get a table lineage like this. There are two types of lineages. There's table lineage and there's column lineage. Table lineage tells you what components go into a table from upstream and what is dependent on it downstream. It's very useful for finding bottlenecks within, or choke points rather, within your data warehouse like this one, where there's a lot of things that are reliant on a single table. And then there's column lineage. Column lineage is a little bit more difficult. Column lineage looks at how individual columns are derived. It's often difficult to track because you have to go upstream to the exact code and find the reference to whatever column you're using to figure out how it's derived. And so you might have to parse through hundreds, sometimes thousands of lines of code in order to fully understand exactly how the column in a table downstream is being calculated throughout the data warehouse. So how do you prioritize what you're going to look over? You can prioritize developing your understanding of individual tables based on the impact of that table. So the closer you are to your raw data, the more likely that table is going to have a higher impact because there's going to be more tables downstream that are dependent on it. You can also just go downstream and look directly at what is dependent on that table, but this might not be feasible depending on how big your data warehouse is. What does investigating data lineage look like in practice? So this is the app that I've been developing called Molecular Data, and it cleanly lays out for you all of the raw tables within your data warehouse and then all of the additional layers of code that you've stacked on top of it. It shows you which tables are high impact, as indicated by this I badge, which tables you're experiencing data loss, as indicated by this D badge. And using the lineage here, I can very easily see which tables are bottlenecks within our data warehouse structure. So if I click on this guy right here, I can see that this one's at the end of a long chain of tables. Or if I click on this one right here, it's also in the same situation. But if I scan, or if I look a little bit more closely, we can see that this one, work orders enriched, is actually a linchpin to our data warehouse flow. We can see that there are many tables downstream of it that are that feed off of it, and so it is critical to the flow of our data warehouse. Now, ideally, our data warehouse isn't built this way. You can see that this is actually a very fragile data warehouse structure where there really aren't any strategic layers or organization to the way this thing is built. So ideally, we wouldn't build the data warehouse this way, but data warehouses, unfortunately, more often than not, are structured this way. So this is the sad reality of the industry right now. So we can see very quickly, we can get an idea of the flow of our data warehouse. We can see what is feeding a table upstream. We can see what is feeding off of a table downstream. And then we can start to analyze the column lineage. So what I can do if I want to get a very quick overview on, say, one of the fields within this table, say labor hours, and I want to understand what's going into there, I can click on this logic button and it'll tell me exactly what is feeding into that field right here. It'll also give me a end-to-end summary in layman's terms on how that field is built. So using this tool, Molecular Data, I can very quickly get an understanding of the way my system works. So the next thing that you need to do is take a look at the transformation logic within your data warehouse. First, you want to try to understand the individual tables within the warehouse. What does each row of each table represent? What is the purpose of that table? What layer does that table belong to if there are layers? Is there a layering strategy to the warehouse? We saw in the demo that there were no layers and tables were sort of all over the place with references going across multiple tables. This is unfortunately very common. It's a huge tell for me when I'm working with the team that they don't have a data strategy or their data strategy isn't clear. So then once you've understood the tables, you want to try to understand the logic within those tables. There are a few classifications of logic. The first is there's cleaning logic. This logic is used to compensate for shortcomings in the data. Either fields are in the wrong format or they're blatantly incorrect and need to be cleaned. Then there's organizing logic. This logic moves, filters, or partitions data based on its characteristics. There's attribution logic. In some situations, we might want to assign a value to a data point depending on characteristics that data point has. So for example, we might want to classify a data point based on the feature or subfeature that it is related to. Then there's aggregation logic. And think about this in terms of metrics. So when calculating a metric, we might want to aggregate the metric based on a business grouping or a time series. There's reporting logic. In some situations, we'll want to organize data in a specific way to make it conducive for a specific form of reporting. And then lastly, there's preparation logic. So in a lot of situations, we'll want to export our data either to some other department. Maybe we export it from our company using an API. Maybe we feed it to a model downstream. And so this logic helps prepare the data to get into the format that's needed in order to export it. So you need to go through your data warehouse and understand what type of logic is in each job and how trustworthy it is. This is very difficult. Ideally, logic is organized very closely to the layer that table is in, but as I said, that's not always the case and can make this process very challenging as a result. Once you've done that, one thing to be aware of that's a very big problem in data warehouses is cascading logic failures. This is worse than a simple cascading failure because when it happens silently. This happens in a lot of data practitioners' warehouses without them even knowing about it. There might be a bug early in a warehouse, like right here, and then it just sort of cascades all the way through the warehouse. And sometimes, as I said, that bug might be something very innocuous or might seem innocuous, like maybe it's a filter that's like slightly incorrect, or a case when statement that tags a data point as being something, but it's incorrect. And as a result, your data going forward from where that bug takes place is incorrect because your logic is making transformations off of incorrect data. And so it can be very innocuous, very hard to detect as a result of like how small and how nuanced these things are. If that transformation or if that bug is in a high impact area, like right here, the impact of the bug will be significant. The other reason why this is hard to detect is because it can happen also in legacy data warehouses where you didn't necessarily write the logic and there might be limited documentation built around it, and tests might not exist. And so you might have to go back retroactively, investigate, build out tests, do whatever you need to do in order to identify these bugs, but it's not always super simple. There are a couple of tests here that I'm going to list out here for you that can help you mitigate these. The first is you can look for decreases in data. This is where you scan every table and you see how many rows it has, and you can make this more complex by looking at the number of rows by dimension, etc. You can also look at data uniqueness. This is the number of rows per that are unique within the data set. Ideally, that stays consistent and you don't have non-unique rows exploding. You can also look at the number of null values. You want to make sure that that is consistent and not increasing too much unless you've got a very distinct reason why that should increase within your business logic. And the last test that you can sort of run is just your basic business sanity test, is like maybe your business metrics or your data downstream doesn't make sense. One last technique to detect a cascading logic failure is you can take a couple of sample rows within your data that you understand how they're supposed to be transformed throughout the warehouse, and you can follow those individual rows, especially if you've got a primary key in place, throughout the warehouse, and you can see how those rows change in the different logical steps within your warehouse. And that's a very good way to quickly find, well, not quickly, but to thoroughly find a failure within your logic. So this is all to mitigate problems caused by poor design, frankly. You want to fix the root cause, though, by building or rebuilding your data warehouse in a series of intentional layers where these failures can't really happen. A medallion architecture is a good way of doing this. It's a simple implementation that the industry is very comfortable with, so that's one thing that you can look at. The next step is you want to take a look at the orchestration of your warehouse. What is the cadence that your warehouse is running on? Is it a streaming warehouse? Is data being run in batch jobs on an hourly, weekly, or monthly basis? And then you also want to understand how data is being loaded throughout your data warehouse. Is there a merge upsert that's happening, and this is where data is updated based on the primary key? Or is there an insert happening? Are there insert jobs happening where records are being appended, or depending on the flavor of insert, data is being overwritten? Next, you want to understand where data is exiting your data warehouse. So look at this could happen with reporting. This could happen with a hosted table that you're sharing out, or this could happen with S3. And this is really important to know because if you re-architect your warehouse to make it more conducive for AI, all of these are dependencies that you will likely have to upkeep and maintain. So you want to make sure that you understand all of your dependencies before you start changing things and potentially breaking things. In conclusion, this covers our deep dive portion on how to explore your data warehouse. It can be a daunting task, especially when your warehouse is thousands of tables, but hopefully this gave you some ideas on how to tackle it. There are many tools out there that can help you better understand your warehouse, one of which is the tool that I'm building, Molecular Data. If you're interested in helping test it, you can apply for the closed beta on my website in the description. And I hope that you find this helpful. As always, if you want to see the next video in the series, please like and subscribe. If you have any thoughts or questions, feel free to leave a comment or shoot me a DM. Thanks again for watching, and I'll see you in the next video.